Hey everyone, in this video we're going to be continuing on the topic of variation, and today we're going to talk about something called a coefficient of variation. But before we do that, I do want to show you a shortcut on how you can calculate some of the stats we've been doing. In the last video we talked about variance and standard deviation, and that took a lot of work to get those calculations. You had to do each value minus the mean, square it, add them all together, divide by n minus 1. It was a really long formula, very easy to make a mistake as well. So fortunately, we do have an easier way to do this on our calculators, and that's what I'm going to walk you through first here. So I'll just do 3 quick steps, and then I have screenshots of the calculator to walk you through more in depth. But if you get it just based off of these 3 little steps, even better. So the first thing that you're going to do is you're going to hit Stat on your calculator, the Stat button. You're going to then hit Enter on Edit, and you're going to enter some data. So you could even take a second and just enter like 5 numbers or something like that. Enter some data into there, type each one, enter, type each one, enter. Now, if it does not say list 1, it's okay. Don't necessarily worry about changing it. If you can figure it out, great. If it says a different, like if it says L3 or something like that, that's okay. Just go ahead and type it into the first list you see there. But take note of what it does say up there. Hopefully it says L1. After you've typed that in, you're then going to hit Stat again. And you're going to go over to Calc. And you're going to hit Enter on 1var stats. That stands for one variable statistics. And you're going to hit Enter. You'll then see a screen where it says List. Now that list should say whatever list you typed your data into. So if you typed in the list 1, it should, by default, it should say L1 there. Hopefully the year says that. If it does not, you're going to need to change that list to whatever list you typed it in. To do that, you're going to hit the little blue button, the second, and then hit Stat, which is list, and then just select which L you put it in there. So if it's L3, then just hit Enter on L3, and that will change it. Otherwise, just keep it as L1. After you make sure that matches up, you're just going to go down to Calculate and hit Enter. And you're going to see a screen. It says 1var stats. And then you're going to see some symbols that we've been talking about. Your first one that you should see is X bar. Looks like this. You should see this sum of X, or that sigma, which is 44. And then you should see the sum of the X squareds, 438. You should then see this SX. That represents standard deviation. I guess I'm just writing the numbers that I got here. So this represents standard deviation. And then that's for a sample. And then you should see this little lowercase sigma x. That represents, and minus, and there's just random numbers, standard deviation for a population. From this, we could easily get variance because variance is just standard deviation squared. So if we wanted S squared, which is variance, all you do would just be to take your other number and square it. So super simple way to get those same numbers that took us a long time to do it. You'll also see if you want to scroll down, you can actually scroll down. There's some more information which we'll talk about in future sections. It talks about there's a Q1, quartile 1, a median, and quartile 3. So you can actually see a median. The median is available in this as well, along with the min and the max. So lots of good stats in that one screen. We're going to walk through some screenshots as well. So again, the first thing that you do is you hit Stat. You're then going to hit Enter on Edit. You're then going to type your stuff into list 1. So type all your data into there. So go through and type that in. From there, you're going to hit Stat again. I forgot that data, hit Stat again. You're then going to click on 1var stats. You're then going to make sure the list says L1 or L3 or whatever you typed it into, then hit Calculate. And you will see, whoops, this screen here, your 1var stats, which gives you, sorry, this is the mean. You don't really need to use those sum of x's and sum of x squareds, but that was part of when we did variance. We had to calculate those. This is standard deviation of a sample, right? S, remember, is sample. And then we got standard deviation of a population. So we won't really use variance that often. As I mentioned in the previous video, variance isn't really used as often as standard deviation. Standard deviation is a little bit easier to work with. It's also a smaller number because it's the square root of variance. So we'll pretty much just mostly talk about standard deviation. All right, so we're going to seek to answer a couple questions today, and I'm going to introduce you to one other new formula, which using these one variable stats will make this formula go a lot smoother. So the question is, do you think that there is more variation in Ohio gas prices, so like yearly gas prices, or snowfalls, meaning the amount of snow over the last 10 years? So in other words, do gas prices fluctuate more? Have they fluctuated more over the last 10 years? Or have snowfalls fluctuated more over the last 10 years? So take a second and just take a wild guess. All right, and then the question is, how could we even determine this? How could we compare gas prices, which are in dollars, like, $3.02, versus snowfall, maybe 5 inches? They're completely different units. We're talking about completely different things. So how could we even make this comparison? Well, it turns out there is a way we can, and that is something called the coefficient of variation. Coefficient of variation is just a measure that expresses the standard deviation as a percentage of the sample or the population mean. So in other words, the standard deviation is 12% of the mean, or it's 30% of the mean. If you don't completely grasp what I'm saying in this point, no worries. Basically what this does allow us to do, though, as long as you can get the calculation, is you compare different populations. They could be completely unrelated statistics. In the case where I just mentioned, we're talking about snowfall and gas prices, right? Seemingly completely unrelated. However, this is going to allow us to compare them. In general, a higher coefficient of variation, just use this CV as an abbreviation, that's a higher variation. So if the coefficient of variation is higher when you calculate it, that means more variation. So it's really easy to compare once you get the formula. If you get a higher number, that means more variation. Lower number means less variation. And so we're going to need a couple formulas. So coefficient of variation, just use CV. Very simple formula. If we're talking about a sample, we are just going to do the standard deviation, which is just S, over the mean, X bar. That's it. And often what we'll also do after this, it's optional, but we'll multiply it by 100. And that just makes it a percent. So you can express it either as a decimal or a percent. I believe your textbook says to multiply it by 100. So this would be for a sample, which we'll pretty much exclusively use because we're going to just look at samples of data. And if we're talking about a population, sorry about that, it's just going to be a different symbol, sigma, because that is our population standard deviation, over mu, because mu is the population mean. That's the symbol that we used. Still times 100. So that's for our population. In either case, it's the standard deviation divided by the mean. So this just gives us kind of like a ratio, which we can use to compare our different populations. So very simple. And with these new statistics we can do on our calculator, the one variable stats, we don't actually have to do the calculations for the standard deviation or the mean, which was the really hard part, right? We can punch it into our calculator. It'll give us those statistics. So then all we're going to have to do is just take the standard deviation divided by the mean and multiply it by 100. All right, let's see if we can answer this question. So I got some data here from a couple different websites. I'll show you here. So the first one is gas prices. So from this website, I just got the gas prices in January, average gas prices in January for the last 10 years. So from 2010 to 2019, which are right here, this first column here. And then I got the biggest snowfall. That's the data that I could find. There's the largest snowfall in each year for the last 10 years as well. So 2010 up through 2019, the largest snowfall. So you can see, it looks like in 2010 we actually had this is the largest snowfall in one day. So we had 9.7 inches back in 2010 on one day. All right, so let's see which one of these has more variation. Well, the first thing that we're going to need to do is get the one variable stats. So what you're going to do is you're going to walk through those calculator steps that I just did. You're going to do stat, edit, and then you're going to type the gas prices into your list one. So you're going to go to 2.650, enter 3.096, enter 3.381, enter. You're going to enter all of those in. There should be 10 of them. You're then going to do your stat calc and then one variable stats. I went ahead and did this, and so this is from our one variable stats. And the two pieces of information we need are X bar, which is 2.59. So that's saying that the average gas price over the last 10 years was $2.59. And then the standard deviation S was 0.633. So then to compute our coefficient of variation, we're just going to do CV equals 0.633 over 2.59. I'm just going to go ahead and do that part first. When you do that, you get 0.244. So that's our coefficient of variation. We can also just multiply this by 100 if you want to and make it a decimal. All that means is just make it a percentage. You just move the decimal place over two places. That's 24.4%. So it's saying that our standard deviation is 24% of our mean. It doesn't mean a lot to us maybe right now, but it is meaningful if we can compare it to something else. So if we compare this to the snowfall statistics, we're just going to go back to our one variable stats. We got to re-enter our list. Just make sure that you clear out all the other ones, replace them with these snowfall numbers. Type those into your list one and calculate the mean. When you do that, you're going to get a mean of 5.42 and a standard deviation of 2.158. All right, and then we can go ahead and do our coefficient of variation. So we do our standard deviation, 2.158, divided by our mean, 5.42. And that's going to give us 0.398, which is equivalent to 39.8%. So now we can make our comparison. Which one has more variation? So did snowfall vary more or gas prices vary more? And the answer is snowfall had more variation because it is a higher coefficient of variation. So there's more variance, you could say. Another way you could phrase this is there is less certainty in the amount of snowfall over the last 10 years than there would be in gas prices. Gas prices don't tend to fluctuate as much as snowfall does. So you could also say that there's more certainty, or you could say more stability in gas prices because it has a lower coefficient of variation. So a lot of different ways you could phrase this. All right, we're going to do one other example here. So let's take a scenario here. We're going to say 3 different families each have 5 kids. All right, and what made me think of this, I was looking for some examples, and my family actually have 5 kids, and I was the youngest of 5 children. So I saw these, decided to make up these numbers, and thought would be a good illustration here. So this turns out is actually my family ages here. I'm the youngest, and then The oldest up there at 41. So that's my family ages currently. So a cool thing with the coefficient of variation is it doesn't matter what the ages are now. You can compare them to, let's just say, the Jones family, which I made up. These are their ages. They have kids that are ages. They have twins, 2-year-old twins, a 7-year-old, a 10-year-old, and a 12-year-old. And how can we compare that to my family, much older now? And then this other family called the Callahan family. They've got a 5-year-old, 6-year-old, an 8-year-old, 12-year-old, and a 13-year-old. So the question is, which family has the most variation? We could also ask the other question, which has the least variation, right? So let's go ahead and calculate coefficients of variations for these three families that all have 5 kids. When we do so, we're going to do the same thing we've done before. We're going to enter the data into our list 1. Make sure that you're clearing out the extra ones. Our last example had 10 data points. These only have 5. So make sure you're deleting out those other 5. When you do so, you'll find that the Jones has a mean of 6.6. So what this is saying is the average age of a child in the Jones family would be 6.6 years old with a standard deviation of 4.56. Okay. The Davis family has an average age of 36.8, and their standard deviation is 3.492. And the Callahan family, a mean of 8.8 and a standard deviation of 3.563. Okay, so let's compare the coefficients of variation. So all we need to do from here is just divide our standard deviation, 4.56, divided by the mean, 6.6. And for that, we'll get approximately 0.690 or 69%. For the Davis family, coefficient of variation, 3.492 standard deviation divided by the mean of 36.8, and that gives us 0.094. So that would be 9.4%. And lastly, the Callahan family, their coefficient of variation, 3.563 divided by 8.8, and that equals 0.404 or 40.4%. Okay, so based off of this, we would say that the Jones family has the most variation. You could say the most diverse ages would be another way to say that, right? Which family has the most diverse ages? Or if we ask the question, which family had the least diversity in ages, or the closest children with the closest ages, that would be the Davis family. Callahan kind of sits in the middle there. Maybe you could say they have the most consistent age, I don't know, age gaps or something like that. So at any rate, that is how we can compare different, you could see in this cases, they were just different ages, different age ranges. So we can compare within the same category. We're comparing all ages. Or we can also make cross comparisons between different categories. So snowfall and gas prices. You could do things like, I don't know, Ohio State wins versus, I don't know, rainfall or temperature or something like that. You can compare completely different categories using this coefficient variation. So reach out to me if you are still unsure on how to do this, especially if you're having trouble with your calculator, and I can try to stop in and help you get that figured out. See ya.